Parent functions and transformations. Today our main focus is going to be the first three examples in our book. Before we get started, we need to remember what a parent function is. So a parent function this is going to be the simplest form of the functions in a family. So I'm just going to say simplest form of a function. Okay, now you learned a bunch last year, and we expect you to remember all of them. I am not reteaching it. Normally, if we were in the classroom, I would have you guys make this list. So you guys learned you've learned linear functions. So that's just linear function. I'll do the parent, I suppose. So that's y equals x. Quadratic. Here, I'm going to just draw the coordinate planes and then I'll go back and do the parents. Okay, quadratic, absolute value, like I said, I'll write the parents in a minute. What else? Cubic. Square root. Reciprocal. Exponential. Logarithms. Okay. So now I'm going to go over what the equation of the parents are. And like I said, we expect you to know all this. I'm doing a super quick overview. You need to remember like the key points, you need to remember transformations, you need to remember what their graphs look like. I'm not going to be taking notes on each individual function. Hopefully if you forget, you have your notes from last year. Okay, so quadratic, the parent, I guess it doesn't need to be perfect because it's just a sketch, is y equals x squared. Thing to remember, this is symmetric about the x-axis. This is the vertex. Absolute value is similar to a quadratic in the sense that it's symmetric about the x-axis and has a vertex. It's just the absolute value of x. A cubic That one's a little bit unique. It has that little flattening out. It's got a turning point. So y equals x cubed. The square root. This one's interesting because it has an end point. Reciprocal, so that's the one that looks like this. You guys did a bunch. This one is unique because it has asymptotes. What else? Exponential, so y equals b to the power of x, and b is the base, and that can change, and then y equals log base b of x is a logarithm. Okay, so here are all of your parents. Like I said, we expect you to know these and remember parts about them, like the vertex, the endpoint, line of symmetry, etc. So the cool thing about every single one of these is, did I miss any? Yeah, domain. So you need to be able to know the domain, the range, x-intercepts, y-intercepts, if it's symmetric or not, if it's continuous, yeah, increasing, decreasing, etc. So the next thing we want to talk about are transformations. So this is also something you learned all last year for every single one of these. And the cool thing about transformations is that every parent equation is affected the exact same way with your transformations. So I'm going to write a generalized equation, y equals, and then I'm going to do some color coding. So negative a, and then I'm just going to use function notation since we have so many different functions. So whatever the function is, and then inside the parentheses we have minus b, and then x minus h. Then close that whole function's parentheses, and then on the outside we have plus k. So basically, everything with the x affects your horizontal values. Everything on the outside affects your y values. So a, remember, is a vertical dilation. Vertical dilations can only be positive. If a is negative, that negative is a reflection over the x-axis, which affects your y values. Moving on to the inside, b is a horizontal dilation, but we're not going to put, well, I'll talk about that later, I guess. If it's negative, it's a reflection over the y-axis. H is a horizontal translation. And remember, it moves the opposite, so if it's minus, then it's going right. And then this is also the reciprocal. And K is a vertical translation. All right. On Monday, you're going to be expected to be able to take any one of these functions, understand the characteristics. So like I said earlier, the domain, the range, intercepts, symmetry, continuity, and behavior in intervals where they're increasing or decreasing. You need to be able to, given an equation, list the transformations and graph. You need to be able to, given an equation, figure out the transformations. So I will say my tips for you, I guess, and then I will end the video. And on Monday, we're not going to do dilation, so that'll be kind of nice for you guys. We'll do those on Tuesday. So my tips are to always list your transformations, even if you're not asked. So this is graph to equation or equation to graph. Always list the transformations. When given a graph, or when graphing, sorry, I recommend making a table. And I can show you what I mean by that on Monday. I think that's really it. Maybe also listing the parent, because that's something students tend to forget as well. So the big one really, guys, is list those transformations. That's always a nice safety net that will get you some partial credit. When you're going to graph, make a table. I always do that just in case. It's just a nice safety net. And then list the parent, because sometimes you get everything right, but then the equation you wrote is actually not the appropriate function. And so that's always just frustrating. So that's it for today, and we'll be practicing this in class.